Welcome all to Kinematics class 13, in which we will discuss about how to solve boat river problems. So the questions related to boat river problem will be something like this. There is a river of width, let's say that is equal to nothing but d, and a boat or a swimmer is starting from point A, and the exactly opposite point on the other side of bank of river is represented by nothing but B. Now the boat can move with different velocity relative to this water. That means the boat can move along this direction with the velocity Vb, or it can move along this direction, or it can move along this direction, like that. So our aim is to find out what about the value of time taken by the boat to reach the opposite bank. So if the boat is moving through a path something like this, so what about the value of time taken to reach at a point, let's say C? And what about the value of its horizontal displacement, let's say, which is represented by x over here? We call it as something but drift. So in the coming topic, we are going to discuss how to find out these things, the time taken to cross the river, as well as the drift of this boat. So in the first case, we are going to discuss about a situation when boat is moving perpendicular to a river flow. So assume that a boat is starting from point A and its opposite point is represented by nothing but point B, and this water is flowing, or the river is flowing with the velocity. I'm just representing it as nothing but VW, that is velocity of water with respect to ground, and the boat is moving perpendicular to the direction of river flow with a velocity, take it as nothing but Vb. So if water is at rest, if the river is not flowing, so no doubt that boat will move through a path something like this and it reach the point P over here. But the water is moving towards right with the velocity Vw. Because of that, even if the boat is moving in a direction which is perpendicular to the direction of this river flow, but the river itself is moving towards right with some velocity, then the situation will be something like this. When the boat is moving perpendicular direction of river flow, but the river is moving towards right. Because of that, the boat will not reach point B over here. It will reach at a point somewhere over here. Let's say that point is represented by C. So if you are observing the motion of river flow with respect to its actual position, then we can observe that it is not going to reach at point B. It is going to reach a point somewhere over here, that I am just representing it as nothing but point C. So if an observer is observing from outside, the boat is moving through a path something like this with respect to ground. So this is represented by velocity of boat, and this velocity is the velocity of boat with respect to water, that I am just representing it as something but VBW. So VB represents the velocity of boat and VBW represents the velocity of boat with respect to water. Now we can write this vector, that is velocity of boat with respect to water plus the velocity of water is going to give the value of velocity of boat with respect to ground. Now if the width of this river is represented it as nothing but d, and the distance traveled by the boat along x-axis is represented by drift, let's say that is equal to x. So in question mainly we have to find out these things. What about the value of time taken to cross the river, and what about the value of its drift? So for the calculation purpose, we'll just resolve the things along x-axis and y-axis. So you can write the velocity along x-axis over here is nothing but velocity of water, and velocity along y-axis is nothing but velocity of boat with respect to water, which is always in perpendicular direction in this question, in this situation. And displacement along y-axis is nothing but the value of width of river, which is represented by d over here. So we can find out the value of time taken to cross the river, time taken to cross the river, by using that equation. T is equal to distance divided by velocity. So distance is nothing but d and its speed is nothing but VBW, velocity of boat with respect to water. Now we can find out what about the value of drift over here, and drift is nothing but displacement along the x direction. So you can write displacement is equal to nothing but velocity along x-axis into time. So you can write the value of drift over here is equal to velocity along x-axis is nothing but velocity of water Vw, and time we just calculate this d divided by Vbw. So from this equation we can find out the value of drift, and from the equation t is equal to d by Vbw we can find out the value of time taken to cross the river. In second part we'll discuss about this downstream flow. That means if the boat is moving with the velocity something like this is representing velocity of boat with respect to water, and it is making some angle theta with respect to the line joining the opposite bank. So over here we can say that if the water is at rest, then this boat is going to reach a point somewhere over here, let's say point C. But if the water is flowing with the velocity Vw, so because of flow of water it is not going to reach at point C, it is going to further move by some distance towards right. So let's say it is going to reach a point D over here. So with respect to ground, if you are observing, so this will be the velocity of boat with respect to ground. So over here we can write again velocity of boat with respect to ground will be equal to velocity of boat with respect to water vector plus velocity of water. Now over here if the width of river is given as nothing but d, and again from point A to D is the distance traveled along the x-axis, that is taken as nothing but drift, let's say that is equal to x. So for the calculation purpose we can resolve the velocities into two components. So component of Vbw along the line AB or perpendicular to river flow, that we can take it as Vbw cos theta, and the component of velocity along x-axis, that we can take it as nothing but Vbw sin theta. Now the same as like in the previous case, what we have to do is we have to just resolve the components along x-axis and y-axis. So along x-axis the velocity is nothing but Vbw sin theta, and along y-axis the velocity is nothing but one component of velocity, or the component of velocity, which we can take it as nothing but Vbw cos theta. Now along x-axis you can observe that along with this the Vbw sin theta there is velocity of water. So the net velocity of boat with respect to ground towards right is Vbw sin theta plus the velocity of water, that is Vw, and velocity along y-axis or perpendicular to the direction of river flow is nothing but Vbw cos theta. Now we can find out what about the value of time taken to cross the river, which is distance d divided by velocity, which is Vbw cos theta. Now we can find out what about the value of its drift, that is velocity into time, that we can take it as velocity along x-axis is nothing but Vbw sin theta plus velocity of water into time. Time is nothing but d divided by Vbw cos theta. So this equation will give the value of drift, and the first equation is going to give the value of time taken to cross the river. The next part we'll discuss about this upstream flow. Over here boat is moving with the velocity, let's say that is equal to nothing but Vbw, and if river is not flowing then it may reach a point somewhere over here, let's say I'm just representing by point C. But because of flow of river towards right with the velocity Vw, so it may reach a point at B, or it can go beyond point B on right side, or it may be somewhere over here, depends upon what about the magnitude of velocity of water over here. So let's say if you are just considering the magnitude of velocity of water is nothing but, take it as nothing but Vw, that is velocity of water, then ultimately boat may reach at a point somewhere over here represented by C. So if you are observing from outside, so we feel that boat is moving through a path something like this, which is known as nothing but velocity of boat with respect to ground. So over here, if this velocity of boat with respect to water is making an angle theta with respect to the line AB, Then we can resolve this velocity into two components. One is along this direction, which we can take it as VBW cos theta, and one component of velocity opposite to the direction of river flow that we can take it as nothing but VBW sine theta. So this component of velocity VBW sine theta is opposite to the direction of river flow. That's why we call it as something but upstream. And here also, if the width of river is d, and we are going to find out the same thing, like what about the value of time taken by the boat to cross the river, and what about the value of its drift over here. So along the x-axis, we can write its velocity will be equal to nothing but the velocity of water VW minus the velocity of boat with respect to water, that is VBW sine theta, and the component of velocity perpendicular to the river flow that we can take it as something but VBW cos theta. So we can find out what about the value of time taken to cross the river, that is distance d divided by velocity, that is VBW cos theta. Now if you want to find out what about the value of its drift over here, or a displacement along x-axis, so you can write the value of drift will be equal to velocity, that is VW minus VBW sine theta into the value of time, that is d divided by VBW cos theta. Now in some question they'll ask to find out what about the condition for minimum time taken to cross the river. So just now we discussed the equation for time taken to cross the river. So that was nothing but d divided by VBW cos theta. So you can write this t will have its minimum value when the value of this cos theta is maximum, or when the value of this cos theta is 1. So minimum time taken to cross the river is something but d divided by VBW, and the condition for this is the value of cos theta is equal to 1. That means the value of theta should be equal to 0. So in boat river problem, we discussed about that angle, which is the angle made by the velocity of boat with respect to water with respect to this line AB. Now if this theta is equal to 0, that indicates that boat is going to move through a path something like this with a velocity VBW. So you can write the condition for cross the river in minimum time is the boat is moving perpendicular to the direction of a river flow. And just remember that if the boat is moving perpendicular to the direction of river flow, it will not reach at point B, it will reach at a point somewhere over here C with some drift. So this will be the actual velocity of boat, and this is representing velocity of boat with respect to water, but it will be able to cross the river in minimum time. Now we'll discuss the condition for minimum drift. So the equation for drift was nothing but we can write x is equal to velocity of water minus velocity of boat with respect to water into sine theta into d divided by VBW cos theta, that should be equal to 0. So for a minimum drift means when the value of x is equal to 0, if you are equating this to 0, then we'll get the value of VW is equal to nothing but VBW sine theta, or you can write the condition for that is the angle theta, sine theta should be equal to VW divided by VBW. So just remember that the value of drift can be equal to 0. That means if a boat is starting from point A, and if it is exactly reaching the point B, then we can say that the value of drift will be equal to 0. And the condition for 0 drift is boat should move in a direction something like this, in such a way that this velocity of boat with respect to water will make an angle theta with respect to the line joining this A and B, and this should be the velocity of water, so that if you are observing from outside, we feel that the boat is moving through a path something like this and it reached the point B, so that the value of drift or displacement along the x direction becomes equal to 0. So from this triangle also we can observe that the condition for this is the value of sine theta. Like from this triangle we can observe that the value of sine theta should be opposite side, which is VW divided by the value of hypotenuse, which is VBW. And just remember that this situation is possible. The value of sine theta cannot be greater than 1. So which is possible only when the value of velocity of boat with respect to water is greater than velocity of water. So we can write the value of drift can be equal to 0 when the value of velocity of boat with respect to water is greater than velocity of water. So this situation, this condition is valid only when in a question it is given that velocity of boat with respect to water is greater than velocity of water. Now let's see if the velocity of boat, with respect to water is less than the velocity of water, then the value of drift cannot be equal to 0, or the minimum value of drift cannot be equal to 0. In this situation, we'll discuss what about the minimum possible value of drift. Drift cannot be equal to 0, then what is the minimum possible value? As we know, the equation for drift, x is equal to nothing but VW minus VBW sine theta into the value of time, that is d divided by VBW cos theta. Now we are going to find out what is the maximum, what about the minimum value of x over here. So we'll use a concept of maxima minima over here. So you can write the value of x is equal to nothing but VW into d divided by VBW cos theta minus, which we can take it as nothing but VBW into sine theta into d divided by VBW cos theta. So you can cancel this VBW and VBW, and you can write the value of this drift is equal to VW into d divided by VBW 1 by sine theta 1 by cos theta can be written as nothing but sec theta minus sine theta by cos theta, which we can take it as nothing but tan theta into d. Now we are going to find out what about the condition for minima over here. So the condition for maxima or minima is the value of dx divided by d theta over here should be equal to nothing but 0. So we are going to differentiate this equation as a function of theta, and we'll equate that to 0 to find out the condition for maxima or minima. So VW d divided by VBW into differentiation of sec theta, which we can take it as nothing but sec theta into tan theta minus the value of differentiation of tan theta can be written as nothing but sec square theta, and we can equate that to 0 to find out the minima. So we can write this VBW into d divided by VW into d divided by VBW into the sec theta into tan theta should be equal to d into sec square theta. So we can cancel this d over here and over here, and the sec theta over here and sec theta over here. So this can be written as nothing but VW into tan theta can be written as nothing but sine theta divided by cos theta divided by VBW should be equal to sec theta can be written as nothing but 1 by cos theta. So this cos theta and this cos theta get cancelled. We'll get the value of this sine theta is equal to nothing but VBW divided by VW. So if the value of sine theta is equal to VBW by VW, that is a condition for minimum drift. So this is a condition for x minimum when the velocity of boat with respect to water is less than the velocity of water. Otherwise, the value of minimum drift can be equal to 0. Hope so that you understood whatever things we discussed in this class. If you are having any doubt, please contact. Thank you.